Now next we will generate the image playground tab. Task, we will use Gemini 1.0 Pro Vision model to process image and receive recommendation and information from the images that are supplied to the model. So we will develop tab 3 image playground. In this subtask, you implement the code for image playground tab and the code to interact with the model to generate recommendation from an image. To write code that render the image playground tab in the app UI, run the following command. Okay. We will view the content of the app underscore 3 py file. Okay, so this is the content. So in the above code, the render image playground tab function builds the UI that enables the app user to interact with Gemini 1.0 Pro Vision model. It creates a set of tab, furniture recommendation, O1 instruction, ER diagram, math reasoning in the UI. You write the code for the remaining tab in the subsequent tasks in this lab. In the furniture recommendation tab, a living room scene is used to perform visual understanding along with the set of additional images of chair, and the code invoke the Gemini 1.0 Pro Vision multi-model API endpoint to get a recommendation of a chair that complements the living room scene. So the code uses more than one text prompt and the images of the living room and chairs and provide that in the list to the model. The part class is used to obtain the image from the multi-part content URI that is hosted in the cloud storage bucket. The prompt also specifies a tabular format for the model output to include the rationale for the recommendation. So now we will update the response util. The response util.py file contain function to generate model responses. We will update the file to add code that generate multi-model response. Now we will modify the main app entry point file. Next, test the app image playground tab. So we will run the following. We will run the app using command provided in the previous steps in the lab. Now we will test the image playground tab. Okay, awesome. So here we have provided 4 tab, furniture recommendation, O1 instruction, ER diagram and math reasoning. So first of all we will see the furniture recommendation. So here is the image of the living room and we need the chair for the living room. Okay, so here 4 chairs are provided. Okay, and our expectation is recommend a chair that will complement the given image of a living room. Okay, so we will click on generate response to see. Okay, awesome, it's generated the response. So as per the response, chair 2 and chair 4 is suitable. So let's see the image of chair 2 and chair 4. Okay, so this is chair 4 and this is chair 2. So and this is our living room. Okay, so it suggested the correct chair as per the living room scene. Okay, chair 2 and chair 4. Okay, so awesome, and the prompt provided is this. Okay, now we will test check the progress. Awesome, it's completed. Next task is analyze image layout. In this task, we will use Gemini 1.0 Pro Vision model to extract information from an image after analyzing its layout of icon and text. Update the image playground tab over O1 instruction. Equipped with the ability to extract information from visual element on screen, Gemini can analyze screenshot, icon, and layout to provide a holistic understanding of the depicted scene. In this task, you provide an image of a kitchen oven control panel to the model and then prompt the model to generate instruction for a specific function. To implement code for the oven instruction tab in the image playground tab in the app UI, we will run the following command. First of all, type Ctrl C. Okay. The code above utilizes the UI of the oven instruction tab. An image of a kitchen oven control panel is used along with the text to prompt the model to generate instruction for a specific function that is available on the panel. In this case, resetting the clock. So we need instruction for resetting the clock, and we have provided the image with the text prompt. Now we will test the app. Okay, let's see the application. Okay, now we will go to image playground and oven instruction. Okay, so here image is provided in the input, and our expectation is provide instruction for resetting the clock on this appliance in English. Okay, so we will click on generate instruction. It's generating the instruction using Gemini. Okay, awesome, it's generated the instruction. Okay, so this step we need to follow to reset the clock. Okay, now we will check the progress. Awesome, it's completed. Next, analyze ER diagram. Gemini multimodal capability enable it to comprehend diagram and take actionable steps such as document or code generation. In this task, we will use Gemini 1.0 Pro Vision model to analyze an entity relationship diagram and generate documentation on the entities and relationship found in the diagram. Now update the image playground tab ER diagram. So in this task, you provide an image of an ER diagram to the model and then prompt the model to generate documentation. To implement code for the ER diagram tab in the image playground tab in the app UI, we will run the following command. First, we will press Ctrl C to stop the application. Now we will execute the code. Okay, it's completed. So the code above utilizes the UI of the ER diagram tab. An image of an ER diagram is used along with the text to prompt the model to generate documentation about the entities and relationship found in the diagram. So this is our ER diagram. Now we will test the app. Okay, it's deployed. Close this previous application. Okay, now go to image playground and ER diagrams. Okay, so here ER diagram is provided, and our expectation is document the entities and relationship in this ER diagram. Now click on generate documentation. It's generating using Gemini. Awesome. So the ER diagram contains the following entities. Okay, and the relationship between the entities are as follow. Okay, and the prompt provided is this. Okay, document the entities and relationship in this ER diagram. Okay, Now we will check the progress. Awesome, it's completed. So the next task is math reasoning. Gemini 1.0 Pro Vision can also recognize math formulas and equations and extract specification information from them. This capability is particularly useful for generating explanation for math problem. Now update the image playground math reasoning tab. Okay, so in this task we will use Gemini 1.0 Pro Vision model to extract and interpret a math formula from an image. To implement code for math reasoning tab in the image playground tab in the app UI, run the following command. First of all, press Ctrl C to stop the application. Now we will execute the code. The code above builds the UI of the math reasoning tab. An image of a math equation is used along with the text to prompt the model to generate answer and other characteristic about the equation. Okay, so this is our equation. Now we will test the app. Okay, let's preview our application. Okay, now navigate to image playground and math reasoning. So this is our image. Okay, and we'll ask the question about the math equation as follow. Extract the formula. What is the symbol right before pi? What does it mean? Is this a famous formula? Does it have a name? Okay, so this is our input. Now we generate the answer. Okay, awesome. So it's generated the result for each question. Okay, extract the formula. This is our formula. Okay, and what is the symbol right before the pi? What does it mean? So this is the answer. And is this famous formula? Yes. So this is the famous formula. Does it has a name? Okay, so it has a name as well. Okay, and the prompt provided is this. Okay, now we will check the progress. Okay, it's completed. Now next task is generate the video playground. So in this task we will use Gemini 1.0 Pro Vision model to process videos and generate tags and information from the video that are supplied to the model. So we will develop tab for video playground. The Gemini 1.0 Pro Vision model can also provide the description of what is going on in a video. In this subtask, you implement the code for the video playground tab and the code to interact with the model to generate the description of a video. To write code that render the video playground tab in the app UI, run the following command. Press Ctrl C to stop the running application. Now we will enter our code. We will check the content of app_4 py file. So this is the content. So the render video playground tab function builds the UI that enable the app user to interact with Gemini 1.0 Pro Vision model. It's create a set of tabs, that is video description, video tag, video highlight and video geolocation. In the UI, you write the code for the remaining tab in the subsequent tasks in this lab. The video description tab uses a prompt along with the video to generate a description of the video and to identify other places that look similar to the place in the video. Now we will modify the main app entry point. Now let's test the video playground tab. Okay, close the previous application, launch again the application. Navigate to video playground tab. Okay, so this is our video. Okay, and expectation is generate a description of the video. Okay, so we'll click on generate video description. Okay, so it's generated a description based on the video. Okay, and the prompt provided is this. Let me first of all stop this. Okay, and close this previous application. Now check the progress. Okay, it's completed. So next task is generate video tags. In this task we'll use Gemini 1.0 Pro Vision model to generate tags from a video. Now we'll update the image playground tab video tags. To implement the code for the video tab in the video playground tab in the app UI, run the following command. So the code above builds the UI of the video tags tab. A video is used along with the text to prompt the model to generate tags and answer question about the scene in the video. Okay, so now we will test the app. Okay, now launch the app. Okay, navigate to video playground and video tags. So this is the image, and our requirement is generate tags for the video. Okay, so this is the response. Okay, and prompt provided is this. Okay, now let first stop this, close it, and now we'll check the progress. So next task is generate video highlight. In this task we will use Gemini 1.0 Pro Vision model to generate highlight from a video that include information about the object, people and context shown in the video. Now we will update the image playground tab video highlights. Okay, so this is the code for this, and we will run the code. So the code above builds the UI of the video highlight tab. A video is used along with the text to prompt the model to generate highlight from the video. Now let's test the video playground video highlight tab. Open the application. Navigate to video playground, video highlight. So this is our video and we want highlight from the video. Okay, so we'll click on the generate video highlight. Okay, it's generated the highlight. Okay, and prompt provided is this. application. Now we will check the progress. Next task is generate video location. So in this task we will use Gemini 1.0 Pro Vision model to determine location where the scene in the video takes place. So we will update the image playground tab video geolocation. To implement code for the video geolocation tab in the video playground tab in the app UI, run the following command. The code above builds the UI of the video geolocation tab. A video is used along with the text to prompt the model to answer question about the video that include the location information about entities seen in the video. Now we will test the app. Open the application. Navigate to video playground, video geolocation. Okay. So our expectation is answer the following question from the video. What is this video about? How do you know which city is it? What street is this? What is the nearest intersection? Okay, we'll generate the response. So this is our response, and prompt provided is this. Let me stop, close the application and check the progress. Deploy the app to Cloud Run. Now that you have tested the app locally, you can make it available to others by deploying the app to Cloud Run on Google Cloud. Cloud Run is managed compute platform that lets you run application container on the top of the Google scalable infrastructure. So for this we need to set up the environment. So make sure you are in app directory. Okay, so we'll change the directory to Gemini app. Okay, now we'll verify the project ID and region environment variable are set. Okay, if this environment variable are not set, run the following command to set them. Okay, so let's see, our project ID is set and also the region is set. Okay, so no need to execute this command. Now set environment variable for your service and artifactory registry. Okay, it's done. Now we'll create the Docker repository. To create the repository in the artifact registry, run the following command. Now set up authentication to the repository. It's done. Now build the container image. We will use Docker file to build the container image of our application. Our Docker file is a text document that contains all the commands that a user could call on the command line to assemble a container image. It is used with Docker, a container platform that build and run container image. To create a Docker file, we will run the following command. now build the container image for your app. Okay, so for this we will run this command. Okay, it's completed now. Now deploy and test your app on Cloud Run. So the final task is to deploy the service to Cloud Run with the images that was built and pushed to the repository in artifact registry. To deploy your app to Cloud run the following command. Okay, it's completed. Now we will check the progress. Okay, so wait for some time, it's still deploying the application to Cloud Run. Okay, we can check here. Okay, awesome, it's deployed to Cloud Run. Okay, so this is story tab, marketing campaign, image playground and video playground. Let's try again. Awesome, it's now deployed on Cloud Run. Okay, so this lab include four tab as shown in this, that is story, marketing campaign, image and video playground. And we have developed the feature one by one and tested it. Okay, and here we use Gemini Pro model to uh, generate our response. Okay, so thank you for watching, and if you have any question, any suggestion, please put down your comment in the comment section, and please like this video, and please share this channel with your friends and colleagues. Yeah, thank you for watching. Have a great day.